Hi everyone, one short video here on some of the properties that show up once you're in vertex form. So I have a graph here that I want to tell you what the equation of it is. It's y equals x minus 2 squared minus 5. And so I want you to notice where that vertex is, right here at the bottom, right, the minimum value of the function. This is the point 2 comma negative 5. And as you see in vertex form, right, you see that that minus 2 indicates that the vertex is at positive 2, and that minus 5 indicates that the y-coordinate of the vertex is negative 5. So our vertex is at 2, negative 5. There's one property that we've talked about before that you may not remember, the axis of symmetry. The axis of symmetry of the parabola is the line that cuts the parabola in half. That would be like the mirror image. The axis of symmetry is really easy to determine if something is in vertex form. It's simply the line x equals 2. It's this vertical line that goes down straight through the vertex. And since it goes through the vertex, it's just x equals whatever the x-coordinate of the vertex is. Let's talk about domain and range. The domain of the graph is negative infinity to infinity, right? It's all real numbers. So remember, we used to write that as negative infinity less than x less than infinity, or you can just write out the words all real numbers. And that's because domain refers to where the graph exists as we look left and right. This graph exists forever as we look left and right. The range is something that's actually changed quite a bit when you have a parabola that's in vertex form. Notice what the lowest point on this parabola is, right? The lowest place it ever reaches is down here at negative 5. So for range, we would actually write this as negative 5 less than or equal to y less than infinity. What that's saying is that all the y values on this parabola are above or equal to negative 5, and then they go on forever. Remember that there's really arrows on the top of this parabola. I just took a screenshot, so the arrows don't really show up. So the range is negative 5 to infinity. And that vertex really helps you determine what that lowest point is, right? If the vertex was some other place, then we would have a different range. Okay, a couple of other important things. One thing is the y-intercept of the parabola. Well, we can see that. I'm highlighting that point right now. It's the point 0, negative 1. However, if that wasn't visible, remember you always find the y-intercept by simply letting x equal 0 and solving for y. And that's because the y-intercept always occurs at a point that's like 0 comma something. Okay, so let me just show you that real quick. Y equals 0 minus 2 squared minus 5. Using our order of operations, we take the parentheses first. 0 minus 2 is negative 2. When we square that negative 2, we get 4. And 4 minus 5 is negative 1. So our y-coordinate is at negative 1, just like we saw up above. Okay, those are really the main properties that I want us to be concerned about with a parabola when it's in vertex form. There's one other case I want to look at, and that's when the parabola is opening downward. So here's another graph, and I'll tell you the equation of it. So this is y equals negative 1, the a value is negative 1, times in parentheses x plus 3, quantity squared. That squared indicates it's a parabola, right? It's a quadratic function. There's the vertex. The vertex is located at negative 3 comma 2. And then let's see, how high is it? Well, the vertex is at 2, so we're going to go plus 2. That's the equation of the parabola, okay? Our vertex is the highest point here, negative 3 comma 2. The domain is the same as before. That's always true for a parabola. The domain is negative infinity less than x less than infinity. Range. Range now is much different in this case, right? Now we see that the parabola exists all the way down here until we get to that level of 2. So 2 is the highest point instead of the lowest point, which means we would say the range is negative infinity less than y less than 2. And that's indicating that all of the y values on this parabola, if you were to take any point along this parabola, its y value is going to be, less than or equal to. It's going to be 2 or below. Okay. The axis of symmetry. The axis of symmetry is just the line that cuts the graph in half. That's this one right here, or the mirror image here. And this has this would be the line x equals negative 3. Remember, so we can take that straight from the vertex. X equals the x coordinate of the vertex. And the last property that we want to talk about, remember this parabola opens downward, obviously. It is the same width as the parent function. And let's talk about the y-intercept. You really can't see it on this one, so this is one where you really do have to let x be 0 and then solve it. So the y equals -1 times 0 plus 3 squared plus 2. That's -1 times 3 squared plus 2, or -1 times 9 plus 2. So you can see this is a reasonable answer of -7. So our y-intercept would be at 0, -7. All right, that's it for now. I'm going to have you guys practice this a little bit. Be sure to stop into office hours if you need help or want to ask any questions.